So the community at Wolfson is exceptionally diverse. We have people from so many different countries and backgrounds.
Hi everyone, my name is Dan, I'm from Brazil.
Hello, I'm Michaela, I'm from South Africa.
I'm Arjun, I'm from Singapore.
I'm from the United States.
I am from the Philippines.
I'm originally from Yorkshire.
I'm from Shropshire.
I'm from Mexico.
I was born in Washington, D.C., but actually grew up all over the world. I spent 6 years in Cote d'Ivoire, West Africa, and 10 years in Tunisia before going back to the U.S.
I'm from Montreal, so I'm French-Canadian.
I come from Jerusalem, Israel.
You know, we have so many different people from different countries, different nationalities, different ethnicities.
Yeah. I really don't know a country from which I haven't met someone.
It's like traveling around the world a little bit.
Everybody is also from somewhere else.
Yes.
Because it's such an international community.
Yeah. But you get so many more interesting conversations with people from wherever, and you also get really good holidays. I'm going to Jordan next month to visit a wolf.
A wolf.
All right. Good evening, everyone. Yeah, it's yet another edition of the Wolfson Entrepreneurial Society series of bi-weekly events where we get people to come talk to you, interact with you about entrepreneurial activities that are going around Cambridge and beyond. And so today we have a unique panelist. At the last event that we had, I did mention to you guys about the first edition, which is the maiden edition of the Wolfson Enterprise Society Competition that is coming up. So we've had our competition, and today we'll be interacting with the brilliant women in science that actually clicked the curve and they won that particular competition. So today we are going to be looking at them. I'm not going to tell you anything about their idea because they are here. They are going to be talking about that, and then we're going to see how they feel about winning the competition and all of that. So today, I would like to use this opportunity to welcome the two co-founders of Lecta, who happens to be the winner of the first edition of Wolfson Enterprise Competition. So Amy and June, if you could take a couple of minutes to introduce yourself.
Thank you for having us here today.
Yeah, thanks, David.
You can go for
we're Lecta, and my name is June. I'm a third-year PhD student in the chemistry department. I'm in Oren Sherman's group. I work with designing supramolecular hydrogels for stem cells, specifically for cell therapy and delivery into solid organs. So I studied chemical engineering undergrad, and I worked for healthcare consulting for 2 years. And I'm just coming from a family of entrepreneurs. It's just been something of my passion for a long time. After deciding to focus more on my sciences and go into more of a regenerative space, I came to Cambridge, met Amy, and here we are.
And yeah, I'm the same as you. So I'm a third-year engineering PhD student here in Cambridge. I'm working with Professor George Maliaris in the bioelectronics group, and my work focuses on biohybrid technologies for my PhD. So this is combining living cells with flexible electronics to try and treat nervous system injuries. So I've moved around between different fields. So I did my undergrad in biology at Cardiff University, and then moved on to doing a master's in nanotechnology. So this was looking at how different materials affect stem cell differentiation. And then I had an opportunity to work for a UCL spin-out for a couple of years, where I learned, I learned a lot about how to, run and start a business. And then I started my PhD, and obviously, met June. And we've, been working on our PhDs and trying to solve a problem and, come up with the idea of Lecta.
Awesome. It's nice to have you guys. So as you already know, I'm David, doing my PhD again in chemistry and part and parcel of WES. And today I have a co-moderator. And so I want to make this conversational, like really interactive with the Lecta team. And so I would like Asaf, who is my co-moderator, to also introduce himself before we go on.
Sure. Yes. So first of all, congratulations to Amy and Jane. I'm Asaf. I'm also a Cambridge student. I'm reading for my Master of Finance. and I'm part of the family of Wolfson, and I'm very excited to be here.
Awesome. Awesome. So I guess I could just, before we start looking at your idea, I want you guys to spend a couple of minutes to tell us, how do you feel being the winner of the maiden edition, the first edition of the Wolfson Enterprise Competition?
Honestly, I think we were ecstatic. I think it was a great experience. I think it was a couple of weeks ago now. And it was a great opportunity for us to really focus down on, our roadmap and what we're trying to work towards at Lecta. Obviously, you'll hear about a few questions about how we came up with the idea, but this has really helped us narrow down, kind of take our idea from out of academia and move into the idea of entrepreneurship kind of thing. And yeah, it's been brilliant. It's been a brilliant experience. We've had a lot of contact with people after this has been advertised. So yeah.
Yeah, we've met some really incredible people through the competition. I mean, leading up to the competition, but also during the competition, especially the final round. We got connected with some really great, I think, mentors at the competition itself. They gave us some really nice questions and feedback, but also afterwards connecting with them. We're really excited to meet some of these judges and move Lecta forward. So yeah, it was great.
So again, still on the competition, what do you find more fascinating about the entire process? From the point you received the competition call through entering for the first round, the second round, and then being called as the finalist and finally winning. What do you find more fascinating about the entire process?
I think fascinating is a good word to use. I think it's been really useful for us in terms of I've never had to do a business canvas before. In terms of we've got a business plan, but in terms of that first exercise of doing the business canvas, it was really condensed. So it was kind of really useful for us to properly think rather than having like a business plan material with lots of research that we'd done. The business canvas was concise. It was a good way for us to really think what was important, taking Lecta forward. And then the pitch itself was actually really useful for us to create and then think of ways that we could communicate our idea and our research over to people that have never heard of neural interfaces before or hydrogel technology. So it's really useful for us as scientists specifically as well.
Yeah, and the fact that it was an open audience, we were able to engage with just anyone essentially who was connected to the Wolfson Entrepreneurship Society, but also just Greater Cambridge. And when we had our breakout rooms, we got some really nice questions that challenged us and got us to think about new avenues and etc. So overall, great. Yeah. Okay.
Yeah, I guess I would imagine how you felt about having to condense your idea in a single page business model canvas. It was the same thing for me when I was trying to also apply for one other competition where you have this amazing idea what you want to do to change the world, and someone just provide a one-page business model canvas that kind of outline everything you have to think about, from funding, your customers, channel of distribution, everything. So yeah, I could imagine how helpful that could be and how challenging it could also be to actually come up with something like that. So yeah, so Asaf, I will let you move in with the next question.
Yeah, sure. So actually, I'm curious, first of all, what is the most, because you said so many awesome things that you learned and you found fascinating, etc. So then for you, what is the one most process of learning that you find significant? And how did you heard about our competition?
Cool. Yeah, so I guess we can start with how we heard about the competition. Newsletters are great, turns out. I received an ad for it, I think through the chemistry department probably. And we were really excited to see where we could go with this idea for Lecta. And so we just applied and here we are. So, and then the first question was about the what was it?
The learning curve. Yeah.
About learning, if you
the learning curve. Do you want to answer that?
Yeah, I think what we found really useful in terms of it's kind of people reaching out to us. So you guys have shared this on social media, LinkedIn, Twitter. And we've had quite a few people reach out to us, which is new to us in terms of scientists. So people have been really interested in what we're working on, and people from people that we wouldn't normally connect with. So I think that's huge thanks to Wolfson Enterprise Society for that. People have been wanting to reach out to June and I, see what we're hoping to do in the future, and literally just chat to us about our technology, which has been really incredible. And we wouldn't have had that without entering the competition. So it's been great. We've learned a lot so far.
Actually, I think that we hear a lot about the Cambridge ecosystem, right? But it's during these competitions where we were like, oh wow, yeah, there is that ecosystem. There's the scientists talking to the judge business school people, talking to the patent lawyers. They all come together in these kind of events when we're all kind of sharing the same excitement for entrepreneurship. So that's been wonderful.
Yeah, networking, powerful. It's a great thing to discover.
Awesome. So again, just to speak to our audience, start bringing in those questions, comments, suggestions, recommendations as this conversation goes along. So we're going to have this conversation for 1 hour, and then the next 30 minutes, we are going to start taking your questions and your comments on the chat box. So whether you are watching us from YouTube, from Twitter, from Facebook, anywhere, just pop in those questions, comments, suggestions in there. We'll be able to get back to them. So I guess the next question I wanted to, before we dive into your idea specifically, I was just curious, how and where did your entrepreneurial journey actually begin? Or did it just begin because you saw the newsletter about Wolfson Enterprise Competition? I don't want to believe that. So you care to share about that, share where that began?
You go for it.
Yeah. Okay. Yeah. So my dad's a serial kind of inventor. He's a little bit of a crazy scientist, but what that ended up meaning for my childhood was that we would sit around often kind of playing around with things we picked up from junkyards. And then I remember, I think I was like 12, and my dad and I, we just sat together and put together some motors and a jar, I think. And then it was this kind of new air filtration system that we created together. And it actually worked really, really nicely because it was just run with water instead of having paper filters. And we were like, oh, this is a great idea. And then we sold it to I think our next door neighbor, who just probably thought we were cute, or I was cute, and then just bought it off me. But yeah, so that was kind of first time where I kind of tried to make something by myself, and then found it to be useful, and then someone else shared the idea, and then was able to make something out of it. And yeah, I guess that's kind of when it began, when I was 12, sitting in that junkyard with my dad. So
awesome. Hey, Amy, what about you?
Yeah, I'm actually, pretty similar. My dad is, I would say, a serial entrepreneur. He's an engineer as well. So I don't know whether I think he's tuning in. So he's listening to what I'm saying now. But yeah, I would say he's pretty much inspired me and all my sisters, I guess, to go into, potentially starting our own businesses one day. So yeah, I'm the eldest of 6 sisters. So it's, I'm the first one to step out into the real world. But in terms of June and mine and June's partnership, Lecta kind of came about through me having a problem with my PhD, and it was over King's dinner. And I am basically, my biohybrid technologies, we're trying to stick cells to flexible electronics with hydrogels as well. But being in a multidisciplinary group, I'm a biologist and engineering, and it kind of turned out that I needed a chemist to help me with this sticking gels to flexible electronics. This is where June came in.
It's funny too, because I'm technically an engineer myself, working with cells, so it was perfect.
So we just discussed this, and June was like, oh, I think we could probably work together and try and solve this problem. So yeah, we just spent a decent amount of time, I'd say, in the lab together, trying to get this to work. And as we mentioned in the pitch, that we're working on a manuscript together, which should be coming out soon, depending on IP, etc. But yeah, it's been a great partnership, to be honest. We've had strengths of coming together, engineers, chemists, biologists, and trying to solve a problem. And but we were lucky that it was hard work, but luck that it worked as well. So
and that we were having there.
I guess first of all, I could say congratulations to all the amazing dads that are inspiring their kids out there. Okay, so it's quite a coincidence that both of you were inspired by activities surrounding around your dad. So congrats, Dad. Congrats, a big congrats, yeah. Okay, but actually you started talking about the next questions which we were about to ask you, which was how did Lecta came about? And actually I was wondering, Lecta, looking at the idea itself and the name, how did that happen? Why Lecta?
Yeah, so so our technology is based on flexible bioelectronics, right? And we combine flexible bioelectronics with biomaterials chemistry, and then also potentially with stem cells to have that regenerative capacity. And so we were thinking around something that would reflect our bioelectronics kind of root. So then we're like Electra, like there was too many syllables there, and then we were like. And then we found this Latin word that's lecta, which is a feminine version of excellence, and reflecting our female two women in science coming together to start something. We thought it was two scientists pursuing excellence, sounding sort of similar to electronics, Electra. That's kind of how we ended up with the name. So. Yeah, it's been
okay. That actually makes sense now that you've explained that. Asta, if you want to ask the next question.
Yeah, actually, it sounds amazing. But as you know, I'm coming from the business world, so I wondered, what is the exact problem that it solved, Lecta, and how much big the problem? So I'm sorry about my neuro knowledge.
That's okay. So in terms of nervous system injuries, so that's what we're targeting at. We'll first aim to target. So there's currently 1 billion people worldwide that are affected by neurological disorders, ranging from Alzheimer's to epilepsy, traumatic brain injuries. And with an aging population, this prevalence of neurological disorders is bound to grow. So we're targeting neurological disorders, and the field of neural implants has grown rapidly in recent years to meet this medical need. So currently there are huge companies out there at the moment trying to target nervous system injuries. So the likes of Neuralink with Elon Musk, and the problem that we're trying to solve is having this foreign body reaction. So would you like to explain the?
Yeah, sure. So our body fights the implants. They're of course made out of these materials that do not mimic the biological our tissue at all, right? And so our body tries to fight these devices with what's called foreign body responses, and what this leads to is just fibrotic formation around the devices. Ultimately, we can't. The devices don't really reach the nerves, and the functions deteriorate over time. And so we essentially, our solution was to make the devices feel much more like the human tissue. So what does that mean? These devices, they're flexible, but they lack the kind of cell binding motifs, the kinds of microenvironment that's required for these cells to thrive and proliferate and differentiate, and etc. And so essentially, we came up with a chemistry that combines the devices covalently, or essentially it just sticks the biomimetic hydrogels with the device. And the problem doesn't seem that serious until you think about this you think about like trying to stick a cling film with a Jello together. No matter how hard you push them together, it's not going to stick, right? Unless there's some sort of chemical treatment in between to kind of bridge that that interface. And so that's the kind of chemistry that brought us together.
Okay.
Wow, awesome.
Yeah, so I guess just going still on the question that Asaf just asked, I could imagine that the problem you are trying to look at now is having that compatibility between the implant that is coming in and then not being able, trying to figure out to make sure that there is no adverse reactivity between the biological system within our body and the implant. That is one. And then the second is the implant being able to stick to that biological system that is coming to interact with, right?
Yeah. And on top of that, the actual, I think the future direction that we're really excited to go into is that these biomaterials can essentially ameliorate some of the fibrotic kind of the side effects of these implants, but also I think what we're now seeing is that these materials can also support stem cell growth. And ultimately, I think the direction that we're going to explore, and Amy has begun to explore, is essentially this regenerative capacity. And so when we think about regeneration, we usually think about stem cells, right? And stem cells don't just grow on devices. Unfortunately, they're one of the most like finicky, impossible to grow, very difficult on a tissue culture. So imagine trying to grow them on a device. And what our chemistry allows is essentially create the microenvironment that then can be combined with stem cells. And we believe that by combining the devices, which already provide symptom treating functionalities, we can add the cells onto it, and then we'll do some proof of concept studies on this, but the stem cell will then also be there for regenerative kind of functionality. Yeah. So ultimately, we're trying to shift the devices of like symptom treatment to kind of like disease modifying regeneration of the neurological kind of conditions that people suffer from.
Okay, is this implant, is there a particular section of the body that you are targeting, or just any kind of implant?
That's a good question. So currently the proof of concept that we've been doing is in the peripheral nervous system, moving on to the central nervous system, so spinal cord and brain. But I think for Lecta, what we need to kind of decide is narrow down that indication, where are we going to target first? Because for academic research, we're trying everything. This is kind of a platform technology, but initially for Lecta, we need to decide, what route should we go to for market?
Yeah, exactly. Because when you start talking to investors, they want to first of all imagine how large your market is going to be, in order to decide if this is something they could potentially invest in going forward. Okay, so I guess that would take me to, I know you've mentioned a bit of the next question I'm going to ask, but I was wondering if you could tell me in specific terms how Lecta actually entailed to solve this problem, and how does it differ from the convention, what is out there currently?
Do you want to go? Go for it in terms of chemistry.
Sorry, the question was, how does Lecta solve the problem?
Yeah, and why should an investor or anyone invest in your idea?
Well, our chemistry, as Amy said, it's a platform, so it can be applied to a number of different problems that already exist. We're looking at peripheral nerve injury, possibly to problems that rise in like cochlear implants, sometimes fibrosis that form, right?
And so I think why we're currently different from existing technology is that we're trying to reduce the problems that already exist with current technology. So kind of like we're ahead of the game, I think, in terms of currently existing technologies are trying to, bioelectronic implants, trying to circumvent the site of injury, connecting one part of the nervous system up to another. So that could be improving hearing, or it could be connecting the central nervous system, so part of the brain, to the peripheral nervous system so that you could move your limbs. But patients often need secondary surgery. So this will be revision surgery. So an implant might last a month. It might last 6 months, depending on the patient. And this is because of this foreign body reaction. And what we're hoping to overcome with our technology and these hydrogels that we've been talking about is that we can prevent this foreign body reaction, or at least delay it based on our experiments that we've shown. So we're trying to overcome an existing problem, and in the future, this will hopefully mean that secondary surgeries or revision surgeries won't be needed. But like June mentioned with the cells, I think long term, maybe 10 years time, we could incorporate cells into this technology in clinic. We're currently doing it in academia, but if this is in clinic, rather than just reducing foreign body reaction, we can hope to integrate our cells with the damaged tissue. So this will be act as not only just circumventing the site of injury and connecting those mismatched nervous systems, but also repairing them, which currently isn't done at the moment anywhere.
So it's a real paradigm shift here, where it's just like, the devices have just always been symptom treating kind of, right? And just to imagine that the device that can actually cure you, we're trying to get to a curative part, I think, and I think the investors who dare to dream, I think this is the kind of exciting stuff that the healthcare space is moving into. I mean, looking at cell therapies that are coming out, like CAR Ts, there's a lot of red blood cell oriented therapies that are now coming out. They're all going through the pipeline right now, and I think stem cell therapies are definitely on their rise, and to be one of the first to combine device technology with the cells, I think that really sets us apart.
Yeah.
Asaf, you can go.
I just want to add, from my experience regarding investments at Extra, and I don't know if you were aware, but one of the most important things to investor is the team. And I can add for you that you look for me like a great team. So it's your product is amazing, but I'm sure whatever happens, you will find another one together and another one. So the human capital is good.
So usually, apart from understanding your market and how investable your idea is going to be, if you're approaching an investor, the person is going to be asking the question, who are your competitors and how are you different from your competitors, right? So I just wanted to make it get clear from what you've said. It looks like your idea will be able to extend the lifetime of this implant. June, I think you mentioned that currently if you have an implant that could last 1 month, 6 months after that, they could become problematic within the body and probably needs to be removed or something. So Lecta is going to kind of elongate the lifetime of this implant. And then in future, instead of just having an implant that you can replace, you can actually have an implant that can regeneratively become some kind of, play some kind of curative role, as opposed to just being an implant you can always manage and remove and all of that. Is that clear? Are my thoughts in order with what you're...
Yeah, no, that's exactly what we try to get across. I think currently our competitors that people would know about, obviously Neuralink and Galvani Electronics, these kind of companies are working on implantable bioelectronic devices. They're trying to move, or are moving towards flexible electronics, which we're currently working with. But as we mentioned before, this strong bonding of hydrogels that have got extra capabilities of reducing foreign body reaction, hosting cells for regenerative capacities, are just bonuses on our competitors at the moment. Currently, we haven't found any competitors
that does anything like
yeah.
That being said, maybe after this Wolfson call, maybe there'll be a few pops up.
Asaf, you want to go for the next question?
Yeah, actually, that is a raise in my thought. Maybe which partnership you think you need in order to actually bring Lecta to the next stage, the mountable stage that you want.
Yeah, so we're definitely looking into partnerships at the moment. We are, well, so we haven't quite reached out to them, so I don't know how much we can tell you on this call particularly, but we're definitely trying to work with different bioelectronics companies, as well as also stem cells or cell therapy kind of companies as well. And because we want to really explore that that collaboration, that connection of the devices and the cells through our technology, which is the hydrogel. And so those are the directions that we're looking at high level.
Awesome. So again, one of the reasons we are having this call today is, again, to show your amazing idea to the world, to help you with this partnership, for people to reach out to you, to start talking to you about this solution, because I believe that you need all the support you can get, because it's really a unique idea that could change the world, really. So, for instance, later on in this particular competition, we have the runner-up, and we also have the Audience Choice Award winners. We hope that in future we are still going to invite them to have this kind of conversation with them on this platform. But then, so most of the questions I'm going to be asking is just that anyone who happens to watch this video after this conversation, or who is there in the audience, can understand better your idea. One of the things that investors or partners who want to work with you are looking at is the team. They want to understand that the team is the right team for the idea. So you might have an amazing idea, but once the team is flopped, there's no way that idea is going in. So can you spend a couple of moments to tell our audience and people who are going to be watching this why your team is the right team for Lecta?
Well, let me tell you. I think Amy and I have already highlighted how scientifically we're just kind of match made in heaven. There was a problem, we had a solution, and not only that, we were so effectively able to address the problem together during COVID times, which I think says a lot about our communication, our kind of entrepreneurial, but also I think technical kind of match. And in addition to that, I think, Amy, I mean, you've really written reviews on this. You're really just the area expert at this point. I think as a almost PhD, almost Dr. Rush. Yeah. And I worked on healthcare consulting before, as I said, and I'm working for Healthcare BC on the side at the moment. I think I've really seen kind of what the companies needs to do to raise that capital, what kind of things to watch out for. And so I think our kind of combination of expertise in terms of sciences, but also business and the healthcare space in general, I think has made our team quite effective. And also all of our mentors and supports.
Yeah, I think also our supervisors as well. They're just, advising us. And Professor George Maliaris, expert, world-leading expert in bioelectronics. So he's helping us with our manuscript, and also Professor Oren Sherman in the field of chemistry. So I think it's also a huge compliment that, we've got some pretty impressive professors that are behind us as well, that believe in this technology. So,
okay. So what is your idea? What would you say? This might not be directly to Lecta, but as we are trying to project you out there are a whole lot of people who might not have gotten to the point where you are, who are entrepreneurial in their thinking, who are thinking of starting their own journey, just like you've started. They have amazing research out there. They have amazing results that could potentially be a rallying point that the society could use to provide solutions to the numerous challenges that we have out there. So what would you say to an entrepreneur out there who is a researcher, who is an idealist, trying to think about how to bring to light some certain ideas to solve societal problems? What advice would you have for them with respect to building the right team, and how to identify the right team and fund them?
That's a good question.
Yeah. So
you could use what works for you. If you believe that you are the right team for Lecta, How did you meet each other, and how did you know that the spark was there for you to come together and start building Lecta?
Yeah, I think, to be honest, as in we had a problem, and we came together as in like, well, I used my expertise, June used her expertise to try and solve a problem, and it wasn't easy. We have worked quite hard to achieve, solving the problem that we had at the time. I think that like working together before we started Lecta really helped us understand like how each other worked, what we were like in terms of, we met at a dinner. We didn't start meeting through like work. So it was a good like experience for like, we knew each other before, then we started working together in like an aspect of trying to solve a problem. And then in terms of actually starting Lecta, it was like, I think it was just, a bit of, a jump. We were brave, I think. Yeah, exactly. We kind of just went with it. We were like, we believe in this. Let's give it a shot. I think, as perseverance as well, I think, in terms of when it's difficult to not give up, but also in terms of, being brave. I think the idea of starting a business is a scary one, and we just went for it. We thought like, well, we've got nothing to lose, I guess. Like, give it a shot.
Yeah, kind of asking like, what if we could do this? And I think just kind of acting upon that question, I think, was kind of the activation energy that we needed to overcome. And when we did, it was, this wasn't our first business competition, of course, right? Like we applied to other ones before, and that was a process that we learned from. And going through that together as a team, I think we saw each other grow, and we helped each other grow. And then I think being able to, frankly, have conversations when we needed to, and learn from them. That I think that all kind of helped us realize that we have a really strong, team working relationship, as well as friendship. Exactly. And I think the organic part, as you said, Amy, about like, things kind of coming together naturally, it did really help. I guess not everyone can, we were really lucky in that. But I think just to go out and have more dinner parties with friends.
I have actually a follow-up question that I just thought about. So do you think that, like in terms of business and entrepreneurship, do you think that, like, for example, Amy, you feel Jane weaknesses and vice versa? Like, this is my question.
Yeah, I think we help each other find our weaknesses and improve on our weaknesses, right? That the best kinds of friends and best kinds of business partners do exactly that. Let's see, like, we had, there were, of course, like from the start, like we were just friends. And so I think it was quite hard to, I think it was like the frank conversation didn't come so difficult. It wasn't so difficult as it might be for someone who's just met each other, and they're now co-founders together, and then they have to have difficult conversations. I think it was quite different for us in that regard. But I don't know. What do you think?
Yeah, I'm not sure. I think we've really gone through like a whole journey in terms of like meeting each other, having a friendship, then actually working together in terms of, I don't know, we jumped in the deep end. So I don't think there's been many friends that I've then started to like work on something quite serious as a problem with. So then we kind of, we worked together in like an academic perspective, and then we're like, let's jump into this with like, maybe we could start a business out of this. So I think we've gone through like, a pretty long journey, and then we had a global pandemic. So then we've been working virtually together, working on manuscripts. But I think, we're both, I don't know, I think we just understand each other in terms of like, we're both really busy working on other things as well as our PhDs. So I think it's just, having that understanding of how each other work as well. I don't know. I don't think, weaknesses is an interesting word to use.
Yeah, exactly. That's
it's so cute. Thank you. But I meant like in business skills, but you gave a better answer about that. So thank you.
Yeah, I guess your story is actually a validation of how helpful networking is, how important networking is when it comes to you're trying to actually solve societal problems, put yourself out there, be able to learn from people, bring different perspectives, work together to solve human problems. It's unfortunate that COVID has made us to miss all the amazing formal dinner that happened around Cambridge. Who knows? It's possible that this COVID has actually killed some of inspiring ideas that would have sprung out of a formal dinner. And I'm just imagining right now, just imagine if Amy had booked into that formal dinner and for some reason said, no, I don't feel like going there. We wouldn't have Lecta today.
Yeah,
okay, so
yeah, that's true.
That already happened once. Our matriculation dinner.
Yeah.
We were supposed to sit on the same table, and I missed my matriculation dinner.
Yeah.
And so we were supposed to meet on the day one of our Cambridge experience, and it took a whole year to meet each other. But
so. That's amazing. That's amazing. Asa, if you want to go for the next question.
Yes. So maybe like in the short term, what do you think is the next stage for Lecta? What you're planning?
Yeah, short term is a good question. We can answer that one. So in terms of short term, we're currently working on a manuscript, which is exactly this technology. But obviously we can't publish that manuscript until we've secured our IP. So this is something that we're juggling between at the moment in terms of finalize the manuscript. We can't submit it until we've sorted our IP. So that's currently the short-term goal. We aren't sure of like a timeline on that at the moment because it depends. Depends on what happens. But yeah, the manuscript is almost ready to go. So we're just waiting for that.
Yeah, and we're continuing our collaborations with some of the Cambridge hubs, so different applications for platform technology. We're also so filing for patents and things like that. And so I think at this stage we are just focusing on securing our IP right now and road mapping, as we've said before, finding out that the target indication, what's going to be our focus for the next step, and finishing our PhDs.
Sounds like a good. Sounds like a good plan.
That is very important. Finishing your PhD. Yeah, I can't wait to finish mine as well. So yeah, you did mention something about the IP and all of that. And the amazing things that we've got partners. We've had that discussion already. Hopefully from next week we can start putting you in touch with all the partners that we have around Cambridge who could help you with the IP process and all of that. So that's one of those amazing things about Wolfson Enterprise Society. We've seen this as a platform to create, build this ecosystem that allows stakeholders, partners, entrepreneurs, people who dream to dare to come together and begin to find solutions to most of those pressing world problems going forward. Okay, so yeah, I guess I know you said the short the short-term goal is an easy one for you, but I'm sorry I still have to ask about the long-term goal, really. So 10 years from now, what do you think? Where do you want to see Lecta 10 years from now?
Oh, in the clinic, if not already. Reaching the patients, hopefully, is our ultimate goal here. That's the short answer. Long answer. Well, I don't know, Amy. What do you think?
Well, I think in an ideal world, that would be our aim. I think we're working with some materials that are already clinically approved. We're improving existing technology. I think that would be a realistic goal, I think.
And we see a lot of excitement for technology like ours, and just like the combining and really pursuing for that like curative regenerative capacity in our therapeutic space at the moment. I mean, and just kind of improving the lives of people. I don't know, 10 years. What is possible in 10 years? Yeah, I don't know, many things.
So are you looking to maybe pursue this after your PhD, or you want to do it as a side hustle where, because you need the money, right? So you can't stay idle focusing on Lecta if the money if there's no revenue stream coming in? So what are your plans? Because these are, to be honest, I have a lot of friends who are into entrepreneurial things, and they've always reached out to me and say, how are you managing this year's startup? And once you finish your PhD, do you want to focus on it, or do you want to work a bit, get some money, that kind of thing. So I was just wondering, maybe people could learn from you as well what you plan on doing. How do you want to match your future aspirations as well as trying to carry out and make sure that Lecta continues to be something that the future can see?
Right. I think both of us are quite keen on continuing with Lecta. And I think that's what's really exciting about it, about being on here and all that, is that this is kind of our start. I think in terms of needing revenue and kind of worrying about our initial success of Lecta, I think biotech and healthcare startups operate in those relatively different ways, right? Of course, compared to tech startups where you can literally generate products within weeks. Healthcare by nature just takes a long time, and investors definitely understand this. And so I think ultimately, I think following our PhD, we would really like to, once we have a working business plan that I think that every investor would want to invest in, I think we're gonna try to seek potentially avenues through grants or different kinds of funds, or kind of more institutional, kind of bigger, more organizational kind of places where we can enter and grow our idea from just the prototypes and proof of concept into an actual product. And that journey, I think, because the investors and investors know for the healthcare space, I don't necessarily foresee that being a total impossibility and that we need to immediately generate revenues. I don't think there's, I think there's a lot of joint ventures and different kinds of partnerships that we can enter with the industry partnerships as well as academic partnership. And that's the kind of path that we're trying to follow.
I see. Asaf, you want to ask the next question?
Yes, definitely. So actually, it totally makes sense regarding what you just said about the healthcare. But if you look again on the short term, how much do you think in terms of funds, how much money, if whatsoever, Lecta need to go to the next level?
Also, are you talking about pre-seed here?
Yeah, it can be pre-seed or whatever you're planning. In terms of money, capital, how much Lecta need?
I think it really depends on which indication we choose. So we don't have that number at the moment, right? But I mean, I think it'll depend on once we choose the indication, what kind of model systems we want the proof of concept experiments done, right? And so we need that killer experiment done, and to identify that, I think, is our first step before even we pursue any sort of financial kind of investment. So right now we're not looking to actively raise funds. I think right now we're focused on honing down the technology, and I think this is also the best time that we can talk to the investors, look for what they look for, but also how we can prepare for when that pre-seed round comes, that we have a killer experiment planned, and also we understand what kind of things to look out for in terms of the number of investors and how big of a initial pre-seed round that we would have to look for. I think these are all something that we're thinking about, but the science needs to come first, which is obvious. I'm sorry, I'm dodging your question.
Yeah, I guess you already touched part of the next question I wanted to ask. I was going to ask if you are looking to raise funds soon, and if you have any thoughts on how you want to go about that. But maybe I could actually rephrase that to say, how soon are you looking to raise funds?
Well, we got some really cool data from Amy.
Yeah, we've got some exciting data, and I think at this stage at the moment, we're in the process of analysing it. And I think in about a month or two, we'll be in a better position to decide, a more realistic timeline, because we've done some interesting in vivo experiments, And yeah, we're in the process of analysing that. So we're really right in the middle of all the exciting stuff right now. So the fact that we won this competition is amazing.
The cherry on top.
Yeah, and it's great. But we need to, once I finish analysing that data, then we'll have a better idea of, a realistic timeline in terms of showing people what we've actually done and how cool this really is.
So just out of curiosity, you are in engineering, Lecta is in chemistry. And I was just trying to look at, there are two ways these ideas can evolve. It could be something that is directly related to your PhD research. It could be something that is related to some skills you've developed along your academic journey or whatever it is. So which one of these is Lecta to you guys?
Can you say both?
Yeah. I think it's obviously like it's an outcome of what we've been working on as our PhDs. It's actually like a side project, as in we had a problem, we solved it along the way. June and I are doing our own PhDs, but it's kind of evolved into its own product in itself. So what do you think?
Yeah, I mean, it definitely stemmed out of our individual kind of specialties. I mean, and I think that's part of the reason why it's also dear to our hearts.
Yeah,
and it's like our little baby. Is that our PhD project is our like baby, but like like Lecta is like our like joint baby. It's like it combines our expertise and our excitement and our kind of hopes for like the future kind of future of medicine kind of, where we can cure diseases and things like that. So I think there's like and then the initial question was actually, is it more like a personal development thing or is it a PhD? And I think it has to be both, I think, because how do you not grow when you go through something like this? I mean, PhD is a personal growth experience on its own. So add a startup to that and it's like that times, I don't know what.
Awesome, amazing. I think just a follow-up. The reason I've asked this is that I think ASAF is organizing a future event. Maybe that's going to be in 2 weeks from now or 4 weeks from now, where we are trying to look at how science, entrepreneurship in science. So basically, we are going to be looking at how people who do research can actually turn those research into an enterprise company and all of that. Okay. So there are a whole lot of people who have got amazing PhD results. I'm a proponent of commercialization of research output. It's something that drives me when I think about research. I don't do research because I want to make publications. That is part of it, but that's not the core driver when I think about research. I think about research as, will I be able to use what I'm doing to solve society problems, to change the world and all of that. So that means that every researcher out there should actually be thinking about, how can I use my research to change the world? But sometimes people are so focused on their PhD that amazing output don't get the attention that it deserves. Okay, because it's not easy to think about your PhD, do that research, want to write up your thesis and all of that, and then still have that side hustle of trying to move that into a product. So how have you been combining these two things? Because we would want people who are watching this to also learn from what you've done.
Yeah, I think actually a big part of it is actually learning to communicate complex scientific concepts to people. I remember the first time we were talking about Lecta, we were like, how do we describe like flexible bioelectronics with like the the MEA technology, and then combines with like whatever covalent chemistry that and then like no one cares. Was essentially what our friends told us. It's like, what does that mean? And then we had to come up with this like cling film jello analogy just to kind of like conceptually, first of all, get down to kind of the core idea. And then it was just like sometimes like I think academics, as academics, we we tend to use these like complex words because they have very specific meanings and they are effective when the audience understands. But I think through Lecta's journey, I think what we've found is that actually just boiling it down to the core ideas and then being able to just convey the basic concepts is just the most important part. And I think maybe as scientists we can try to do that more. I think it's something that I found. Do you have any?
Yeah, no, I think also what's like how, I don't know how to say it, in terms of how June and I came about with this idea and actually the academic problem that we're trying to solve, I think it was really down to just like us being normal people having dinner, talking about what we're working on, talking about, you know, the problems that we're having, and we're in different fields. I think if June and I hadn't met, I don't know how we would have met in another way. In terms of June's in the chemistry department, I'm in engineering, another end of Cambridge. There aren't really many opportunities for us unless we bumped into each other walking on the street, but I wouldn't have then spoken to June and asked her what she does for her job. It kind of, I think Cambridge really helped in the fact that it doesn't it gives you opportunities to then, you know, like events at Judge Business School or like Wolfson Enterprise Society. If we were all in person, it gives you opportunities to just like, you know, have a drink and talk to each other, or sit down at dinner and, you know, discuss your work and go, oh, actually, you know, your skills could be really useful to this problem I'm trying to solve. And then it's kind of like also giving something an application, like a useful application, like you say, if like someone's focusing very specifically on something in their PhD and they don't necessarily have an application for it, just having conversations with other scientists is really useful. I think Cambridge is really good for that.
No, that's amazing. I hope those who will be watching this lecture and those who are on here watching will have learned a whole lot from there. And I myself, while I'm talking to you guys, I'm also learning some skills. You know, you can never tell. So thank you for sharing. So Asaf, you wanna take on the next question?
Yes, sure. So the next question, going back to business and business and scientific. Maybe you can share with us your thoughts about potential risks regarding Lecta.
Yeah, so 90% of startups fail. I think that's the stat. So they're definitely against. But that being said, I think so, and also like I think there's many risks that we're gonna face on the way, and we're realistic about it. Regulatory, scientific, partnership, IP. I mean, also we're PhD students after all, right? Coming straight out of our PhDs, like despite some experience that we bring to the table, we're not at all an industry expert. So that's also against us. But I think at the same time, I think we're a really great team and we work really hard together. And I think we got some incredible people that we met through our journey. And I think the people that we're gonna meet on our journey onwards, I think that's gonna help us really face some of the obstacles and overcome them, hopefully. And thank you. I think the cling film jello analogy is great. Thank you.
Okay, so I think we can actually look at some of the questions that we have from the audience. We take them on and we can come back to the remainder of the questions that we have. I just wanted to make sure that we are keeping to time. Thank you, chemistry department. We already having a reaction from the department where some of these ideas are evolved from. So thank you. Tom, you want to start giving out those questions? Let's take the one from Raphael.
Can we see the question?
Yeah.
Okay, so Raphael is asking, he said, when did Lecta actually start?
Well, I think 2020, 2021, that time frame. So it's like it's a COVID baby.
Yeah, definitely. It was actually around March last year. I guess we had the labs closed and we gave it a shot. So I think it was around March, wasn't it?
Yeah, it was.
Doing our research,
Yeah, I mean, of course, the research itself went back a few.
Yeah, we got
that.
set with like lab. Oh yeah,
right.
Yeah, so we started the research about 2019.
Yeah, I think so.
Yeah.
End of 2019, and then it started to work quite well, and then we saw an advert for one of these business competitions, and that's kind of when we began. So yeah.
Yeah, so it's great to actually hear news about some of these great things that actually came out of COVID.
Yeah.
Because COVID has been a miserable experience for humanity. But then, yeah. But then when we hear all of this and seeing that people are still being adaptive to the situation and still trying to change the world. So yeah, and just listening to you about when you started, I can like how fast Lecta has actually gone. Just 2020 to 2021, and you're already here.
Yeah, I mean, well, we wouldn't say we're already there. I think there's still many things to get through. But I mean, yeah, I think these things, that's the beautiful thing, is that I think once we have the concept and once we actually even get to the technology, I think the business side, it just kind of comes very smoothly if we have the science. And I think healthcare startups, of course, is like incredibly difficult, right? And it's a tough journey. But at the same time, I think when we try to focus on good science and we get good science around us, like in the Cambridge Hub, I think it becomes. Yeah, it does happen a lot faster than one might imagine.
Yeah, I think also what really helped was that when it might sound funny, but when you're really passionate about something and you've got like a great friendship, you really want to be working on something. Yeah. And in terms of like, COVID, and I think my lab was shut for at least 4 months.
Oh my God, yeah.
You don't really have anything else. You can't go into the lab. We normally go into the lab every day. So we're like working on something, but okay, this could be really cool. Let's do some research. Let's work on this. And it was kind of, it wasn't a chore. It was more like we wanted to do it. We were really interested in it, and it just kind of progressed in that way. And yeah, COVID meant that we were spending less time in the lab, that we could do more market research, for example. It was
like no time at the pub, so that we just sit around at home.
But I guess I could say that COVID might have slowed down the experimental part of Lecta, but then facilitated the go-to-market strategy that you guys need to develop going forward. So that's still good. You try to use something that could have been negative and turn it into something positive. So that is great. Tom, can we take the first question from chemistry department before going back to the second question that Raphael has asked?
Yeah, here you go. Are you working? Sorry, go ahead.
Go for it, Asaf.
Okay, so the Department of Chemistry asking, are you working with Cambridge Enterprise?
Yeah, so we are working with many of the organizations at Cambridge, including Cambridge Enterprise. We are currently assessing, our kind of patent strategy and things like that.
Yeah.
So
Cambridge Enterprise are also really useful. So we reached out to them, I think, last year. And in terms of putting us in contact with like
entrepreneurs and
they have
experts in residence.
They have a program called Experts in Residence. So we had some like NDAs signed, and then Cambridge Enterprise put us in contact with people that were, obviously our field is very niche, but people that were experts in the healthcare field that could kind of sit down with us and speak to us about our journey and how we plan to move forward, and advice they could give us in terms of how we should plan to secure IP, whether we want to license this or what route we would go down. But obviously everyone has different opinions. So we've had different things said to us by different experts, but that was thanks to Cambridge Enterprise. But we obviously need to, we needed to finish certain parts of our manuscript before we could then finish off securing this IP. So it's been we're in I don't know how would you describe it. We're in the middle of it at the moment.
Just to add to that, the good news is also that Cambridge Enterprise actually sponsored, they're part of the sponsor for Wolfson Enterprises competition. And the CEO, Tony Raven, happens to be one of the judges for the competition itself. And so one of the sponsorship terms and condition, if I may say, is that they're going to support us, help us to support those winners and finalists who came on board the Wolfson Enterprise competition. So hopefully from next week, I've spoken to Tony about that, and we'll be able to put you in touch with them for you to continue having that conversation in another direction, you know, going forward. So I guess we could take the second question from Raphael.
Yeah. So.
Now, okay, we could go for this. Then later we can come for Raphael. There's another question anyway. So Namira is asking, how did you approach your supervisors with this idea? Did you ask their opinions right in the beginning or something?
Well, because I'm working in both of us work in a multidisciplinary field. I feel like, honest answer is that we had to kind of solve these problems ourselves. So we just jumped in, and I had a problem, and June was, June, like, let's try and solve it. So we were solving the problem. We then solved it, and it was really cool. So then we kind of pitched the idea to our supervisors once we'd solved it. That's kind of right, isn't it?
Exactly.
So then, they were kind of delivered this on a plate, kind of like, okay, girls, you've got something really cool here. And they've, really helped us in terms of, letting us know whether we're going down the right route, whether the science is right. Like I think that's the great thing about doing things in, academia, is that you've got your, experts in the field as our supervisors who are professors, in engineering and chemistry, that could really, give us a confidence that, like, you guys are working on something that's really cool here. And that was just moved on from there.
Yeah, exactly.
Also, it's amazing, really, because, for instance, I've always believed that at the heart of commercialization of research output is this interdisciplinary collaboration that needs to happen for something to kind of evolve out of it. So Lecta is a typical example of validation of how the world is moving and how different disciplines can actually collaborate, come together to see stuff going forward. So for your supervisors, even if they are not interested in the company or something, for them, it would have been a collaboration, an interdisciplinary collaboration for them, which is a positive for them. They can expatiate on that, move forward with further collaborations in that field. And then for both of you coming in different field and coming together to build all of that, it's great to see that your supervisors are actually supporting the stuff that you are doing going forward, because sometimes it could be challenging if you have that discussion and your supervisor feel like, you just have to focus on your PhD when you're done with that.
Yeah, I think we were lucky in that we were solving a problem within our PhD.
Yeah.
And then also it also happened to be something that could potentially become a business, and both of us were also interested in business. I think also our professors, both Oren and George, are quite they're quite open to different collaborations. And also, I think individually they've also co-founded companies before.
So they've got like a good entrepreneurial outlook as well in terms of any opportunity.
Like Oren's IQ.dot, and I think George has some. And so it's that was definitely helpful. I think it could be a challenge if the professors aren't as keen potentially on this kind of entrepreneurial journey, because it is a lot of time. But because it was overlapping with our PhD, I think that was definitely a helpful bit.
Okay, I guess I really like this question from Raphael. I think he's already asking a question like an investor. This question of a venture capitalist or angel investor is going to ask you, what differentiates you really? So do you want to spend some time to tell us how Lecta compares to other hydrogel being made out there?
Actually, Lecta's chemistry doesn't, what is it? It's not, the selling point isn't necessarily the gel itself. It's the selling point is actually that the ability to be used as a platform to be able to use different types of hydrogels. And these hydrogels can have biological or chemical functionalities, as well as mechanical properties that can be different. And I think that ability to multiplex the material itself. I think that is what sets Lecta's technology apart from a lot of what might be out there for different kind of bioelectronics fabrication technology. But yeah, so there are gajillion hydrogels out there, as you know, and each of them are slightly different. The beauty of Lecta is that we could probably use a vast majority of those materials, including probably a lot of the ones, or most of the ones that that work in this type of chemistry that are FDA approved. So, I mean, as we said in the pitch competition, I think we're not recreating any sciences here. We're combining two vast areas of science, biofabrication and bioelectronics, and we're creating that bridge. So, yeah, that's Lecta.
Awesome. So just a kind of follow-up question on what Rafael was still asking. I'm just curious, are you trying to say, is it possible that Lecta is going to be one product, or is it going to have a different product line? Because if you are going to have different hydrogels, am I right to think that you will have to develop different platforms for each of these interactions?
Well, I think the whole concept of platform is that we can use it for different applications, right? So yes, I think depending on which indication path, what kind of devices, what kind of applications we're going forward with, our technology is going to be going to enable kind of picking and choosing different components, picking and choosing different kinds of functionalities to attain the kind of product that we want at the end of the day.
Yeah, I think our main focus is kind of this like personalized medicine approach that depending on what condition a patient's suffering from, that we can adapt our technology for that. So that's what we're currently doing in the academic setting in animal models, proof of concept. But that's huge advantages that at the moment current bioelectronic devices, standard rigid electrodes, for example, things like deep brain stimulation. Every patient normally has the same device implanted, but the future of bioelectronics is kind of going down that regenerative medicine route. And our advantage is that we can offer this personalized approach, which we don't think any other competitor can at the moment. So we're kind of ahead of the game, and I think it's a great selling point of our technology.
Okay. So, Asaf, you want to ask, there's this other question from Twitter.
Yes.
By Hugoko.
Oh, yeah. So, Hugoko is asking, how is it being woman in science?
I have to answer this, I think.
It's good to be two women in science.
Yeah, I think so.
I think these kind of occasions give us platform to speak out as women in science, right? So we really appreciate you guys organizing events like this. I used to run this thing called Girls in STEM, where we try to get young girls to be interested and stay in sciences. And I think these kind of events are fun, but I think ultimately it comes down to like PhD students like Amy, who talks about her research, to like inspire young girls to actually like find a mentor or like kind of someone to look up to, right?
Yeah, I think it's good that we do a lot of outreach together as well, independently. So I feel like, giving us a voice is, just a great opportunity, I think. And I would say the Indian engineering department is, as a woman in science, it is good to, work with another woman. I thought, my department is, I think it's quite common that there's, a lot of men that work in the department. So it's, really nice that we've got like an all-female team.
Exactly. And I think it's a strength as well, I think. It's just, we're here for support. And I think it's slowly changing, right? I think the female founders, there's more and more the VCs are looking out for more. I think women sometimes are like more risk averse, or I don't know. I think there are different kinds of statistics out there that are for or against women in science, or women who are at the top, or like we're running businesses. But I think we're just here to do some good science and make some feel good changes.
Yeah.
Yeah, I think I really like this question, and so I'm going to build on that question. Let's assume, I don't know who is watching, but let's assume that a young girl out there bumped into this video and being inspired by the fact that two women in science trying to revolutionize a neurological disorder using Lecta and all of that. They're going to be inspired, but I was wondering if you could take a couple of minutes to share maybe some obstacles that you face in your journey and what helped you, how you navigated your way through to actually start thinking that, yeah, I can actually do this.
That's a good point. I think, okay, where do I start? I think I've been really fortunate growing up that, I've got 5 sisters, so I've always been surrounded by women. And obviously, as I mentioned, my dad, I feel like I never felt like I wasn't able to do certain things as a woman, which has been really fortunate. I don't think that's the case for everyone. But I only realized, the difficulties that some women face when I reached my master's level. I think this was when there was like 5 girls on a course of like 40 people. And that was my first, I was quite late in my academic career, let's say, because it wasn't at school, that there weren't many females in a room. So in terms of, like speaking up, being confident about your opinion, I feel like you just need to be brave. I feel there are some times when I feel like if I say something, it might not be, I don't know, I'm not as confident. I feel like as women, sometimes we suffer from imposter syndrome, which we shouldn't. And then, I really jumped into, doing a PhD in engineering, not thinking that, it would be a problem being a woman, and it isn't. There's just, not many females, representing the engineering department. But I was lucky to meet June, and also there's been great mentors along the way. That like my undergrad supervisor was a female professor, my supervisor for my dissertation was a female, and I think just along my journey I've been inspired by other women. So anyone that's listening, if you're in school and you want to become a scientist or pick science subjects, don't feel that like if you're a woman you can't pick them, because it's a great opportunity, I think. And
you could do it, like you could do it. Exactly. I mean, and also I think like our departments are, of course, like there's fewer women, right? But I think in these kind of spaces also, when we find allies like George and Oren's been so incredibly supportive, and I think finding female and male mentorship who are willing to support us throughout our kind of like academic growth. I think finding mentors, I think it's the most it was the most valuable experience for me, and I hope for any young girls watching out there, like look out for those female scientists coming.
Okay, awesome. So that's a thank you from Namira regarding your question. So I guess we are about to draw the curtains close, really. I guess at this point we could potentially take some few times to say a final few words to our listener and all of that. Asaf, it looks like your head is better there. Thank you. I could actually remove this further. Okay, so maybe we could start with who wanna go first? Final remarks. What do you have to tell women in science out there, entrepreneurs out there, researchers who've got amazing ideas that could be commercialized, people who are afraid of daring those limits that you have actually there on your own? What are your final words to them?
It's a good one. I'd say, back yourself, don't give up. I think we've taken a few risks in terms of research, deciding whether to start a business. Also I think important is finding a good person to start this with, have confidence in them, know that you can be completely honest. It's hard work. I mean, I'm not gonna lie, we've had some pretty late nights over the last year, trying to get things done for certain deadlines. But we've been honest with each other in terms of working late, getting our lab work done, or What would you say in terms of?
Gosh, I feel like you said everything that was in my mind, essentially.
Yeah.
Okay. So because Amy has said everything in your mind, let me have you answer a different question. There are going to be people who probably want to reach out to you guys. It could be angel investors, it could be venture capital firms, it could be people who want to partner with your science and all of that. So how would they reach out to you, and what do you have to tell them?
Yeah. Please send me an email, connect on LinkedIn. My email is, can I say this on a live TV maybe?
Well, I guess they could get you on LinkedIn with your full name.
Yes. June Park, PhD student.
Yeah, I'm going to do that's his name, June Park.
Would love
and that is Amy Rochford.
Okay. Yeah. And also in terms of anyone wants to reach out for us, we're always looking for mentorship, anyone with advice in terms of getting devices through clinical trial or developing medical devices. Obviously, if you've listened tonight, you know what our strengths are and what we're kind of working on in terms of an academic perspective and commercializing it. But we're also looking for people in the entrepreneur space that are willing to give us mentorship or help us or join us or speak to us.
Awesome. Asaf, do you have a final word for our listeners before we close the course?
I think they should reach out and hear the last echo of Amy Jane. I personally really believe in this team and the idea. And thank you very much for joining us today. It was a pleasure.
Awesome. So thank you, everyone. Thank you, Amy and June, for making our time to speak to us about your amazing idea. I can't wait to see where this goes from now. And just remember, you can always reach out to us in any form. We can always link you up to all our amazing mentors and partners who we are working together. That's the reason Wolfson Enterprise Society exists, for people like you. So thank you very much for coming on board, and thank you to our audience for tuning in Thursday. Again, this recording is going to be live on YouTube, on Facebook, Twitter after this, so you can rewatch it, you can share with your own networks and all of that. Until then, meet us again 2 weeks from now for another event. Thank you very much all.
Thank you very much.